Hi everyone! Today let's talk about section 7.2, trig integrals. Big idea! A lot of wicked-looking integrals can be computed using trig identities and substitutions. Big skills, you should be able to find the antiderivatives of products of powers of sine and cosine functions and products of powers of tangents and secant functions. So in this session, we're going to learn how to solve three types of trig integrals. The first type, integrating powers of sine and cosine. So you're going to have powers of sine and cosine. So where m and n are non-negative integers. So here is the methods. Depending on whether those integers are odd or even, we can separate into three cases. First case, when the power of sine is odd. Okay, so when the power of sine is odd, then we can split one factor of sine at the end. So you're gonna split one factor of sine x at the end, and then remaining you're gonna have a even power of sine x and with some power of cosine, right? Because this guy is an even power, so you can change it in terms of cosine. So using the trig identities, sine squared plus cosine squared equals 1, so that you can get integral of functions of cosine x and then sine x dx. Now we can use u substitution because we can let u be cosine x, and then the du is just gonna be negative sine x dx. Okay, so this is minus du. So far so good. Okay, so second step. If the power of cosine is odd, similarly, we can split one of the cosine at the end and the remaining change in terms of sine x. Well, in this case, we can also use the trig identities cosine squared equals 1 minus sine squared. Okay, then we can let u be sine x and let du be cosine x dx. Okay, so yeah, as long as one of the power is odd, then you can split a factor and then you change the remaining even powers in terms of the other trig functions. Okay, so what happens if both of them are odd? Well, then there are two ways to solve. You can either split the cosine at the end, or you can split the sine at the end. And your u is going to be different functions, either sine or cosine. But both ways work. Okay, if both of them are even, well then we cannot use the u substitution. We need to use the double angle formula. So here is the double angle formula. I suggest you to separate it because then later on it's more convenient when you want to integrate. Okay, so here is the double angle formula. So you can see if it's even power, we can double the angle, but we can reduce the power. So this can help us to reduce the power, and then we're able to integrate. This is just a integral of a constant. It's just that constant times x, and we know how to integrate cosine, right? Okay, so let's work on examples. Okay, first one. You see, the power of sine is odd, right? So we're gonna split a sine x, one factor of sine x at the end. What's left? Sine squared, right? And then what do? Change the sine squared in terms of cosine. So sine squared is 1 minus cosine squared. Parentheses. Sine x dx. Then we're ready, because now we can use u substitution because the derivative of cosine is sort of sine x, right? So we let u be cosine x, du equals sine x dx, but negative. Okay, be careful with that. Then our integral becomes, okay, so we'll have integrals 1 minus u squared, and then sine x dx is minus du, so we can move the minus in front. We can also use the minus to distribute, so then we can have u squared minus 1 du. Right? And then we can continue and integrate it. So this is u cubed over 3 minus u plus c. And at the end, what is our u? That is cosine x. Cube over 3 minus cosine x plus c. So far, so good, everybody? Alright, let's continue. So actually, the powers not necessarily has to be positive integer. As long as one of them is positive integer and we can use the method is good. So the other one, it can be negative numbers and it's not necessarily integer. It could be fractions as well. Okay, so let's look at this one. Because the cosine is odd, so we're gonna split the cosine, one factor of the cosine at the end. What's left? Cosine squared. Sometimes my students get confused. Shall I change the sine in terms of cosine, or shall I change the cosine in terms of sine? Well, I would say look at the tail. Look at the tail, because I would say this looks like an animal. This looks like an animal, and this is the tail, right? Look at the tail, and then you can figure out what animal you are. That is, okay? So look at the tail. Cosine x is the derivative of what? Wow, it's the derivative of sine, right? So that's why I want to change this. So we want to change this in terms of sine. Okay, so change this in terms of sine x. Alright, so then we know cosine squared is 1 minus sine squared. Now we're ready to do u substitution. We can let u be sine x. Then du is cosine x dx, right? And so this is u to the negative 2, 1 minus u squared, or this is du, right? Remember, we don't have product rule, so we multiply out. U to the negative 2 times 1 is u to the negative 2. The u to the negative 2 times u squared is actually 1. See? When we integrate, we add 1 to the exponent divided by that exponent. And then integral 1 is u. And what is u? U is sine x. So we have minus 1 over sine x minus sine x plus c. Be careful, because I have students make this mistake before. The student wrote this. Is he right? No. Don't write this. Because this guy is the inverse trig function. This guy does not equal to 1 over sine x. And what we need here is 1 over sine x. So be careful, everybody. So don't write that. Okay? So, and right now, in order to help you to understand this tail thing, let's watch a YouTube video. So I really want to use the funny story to help you to memorize the formula or understand it. Okay, let's look at this YouTube video.
Did you ever see that tail? A pig's tail. Did you ever see a tail? My curly twirly tail.
A zebra's tail to flick the bugs.
A kangaroo's tail to sit up. Oh no, they're not my tail. Did you ever see that tail? My tail. A pig's tail. Did you ever see a tail? My twirly tail.
A peacock's tail for beauty.
A dog's tail to say hello.
Oh no, they're not my tail.
Isn't it interesting? Okay, we won't watch the whole video. So, yeah, I find this sound when my daughter watched the YouTube. Okay, I think this is quite interesting. So you look at our tail. If the tail is sine, okay, if the tail is sine, you know our u. Sine is the derivative of cosine, so our u should be cosine. If you see our tail is cosine, you know the u is sine. Okay, so keep this in mind. Let's continue. Alright, so you can see this. So I suggest you to pause the video here and try to work on this problem. And are you done? Okay, you can see the power of cosine is 5. 5 is odd. You might say, hey, isn't it the power of sine is also 3 odd? No. This guy is actually cube roots. So this is sine cube roots. Odd or even, we only talk about integer, not fractions. Okay? So here, the powers of cosine is odd. Okay, let me change back my color. Okay, so that's why we're gonna split the cosine. So we have sine x 1/3, and we split one cosine at the end. What is left? We get cosine to the 4 in front, right? So we're gonna change this in terms of sine. So how do we do that? Well, cosine to the 4 is like cosine square and then square, right? So, and now we know cosine square is 1 minus sine square. So far, so good, everybody. And we have cosine x dx. Okay, and then what is next? Alright, what's next? We're gonna use u substitution, right? We're ready. Let u be sine x, then du is cosine x dx. And so this is u to the 1/3. This is 1 minus u square, and then du, right? So, remember, we don't have product rule for integrals. And, even though the integration by part we learned last time, it only can help us to solve certain kinds of products, not all types of products. So here, let's multiply everything out. This is 1 minus 2u squared plus u to the 4. Why? Why? Because a plus b squared equals a squared plus 2ab plus b squared. And if it's minus, then you flip the middle sign to be minus. And then continue to distribute it. So we have u to the 1/3 and minus 2. U squared times u to the 1/3 is u to the 1/3 plus 2. Remember, it's plus 2. Don't multiply by 2. X to the a times x to the b is x to the a plus b. X to the a to the power b is x to the a times b. But here we're multiplying, so we add the exponent. So that is 7/3. And u to the 1/3 times u to the 4. 4 is 12/3, so 13/3. Let's integrate, add 1 to the exponents. 4/3 over 4, 3, flip it on top. Add 1 to it, so 10/3, 10, flip the third on top. Add 1 to it, so 16/3 and 16/3. Alright, so we can plug in u is sine x, so 3/4 sine x to the 4/3. And 2 and 10 cancel, we get 5. 3/5 sine x to the 10/3. And 3/16 sine x to the 16/3 plus c. So this is our answer. So far, so good, everybody? Alright, next. Okay, so next, do you see the power of sine is even? So remember, if one of the power of cosine or sine is odd, we're going to use U substitution. But if both of them have even powers, then we're going to use the double angle formula to reduce the power but double the angle. So here, let's think of it as sine square, okay? And then, what's sine square? Well, that is 1/2 minus 1/2 cosine 2x. So I hope you can memorize the double angle formula because we will use it a lot in our course. And throughout all the exams, we're not providing formula sheets. Okay, so let's continue. We multiply out, right? So 1/2 squared is 1/4 minus 2 times 1/2 times 1/2. So 1/2 cosine 2x plus 1/4 cosine 2x squared dx. Well, do you see this guy is squared? Again, let's use double angle formula again. But the double angle formula here is 1/2 plus 1/2. But when you double the angle, what angle do you get now? Yes, 4x. So what is that? Well, you see, when you multiply it out, you get 1/8. 1/4 plus 1/8 is 3/8 minus 1/2 cosine 2x plus 1/8 cosine 4x. And let's integrate it. So 3/8 just times x. Here is sine 2x and multiply by 1/2 in front. And here is sine 4x, but multiply by 1/4 in front. Alright. And yep, let's multiply them together. So this is 1/4 sine 2x, 1/32 sine 4x plus c. So far, so good, everybody? Alright, so we have learned how to integrate powers of sine and cosine. Next, let's look at how to integrate powers of tangent and secant. Okay, so the methods are kind of similar, but this one is more special and harder. Okay, a little bit harder. So okay, if the power of tangent is odd, we want to use the substitution for u is secant. Okay, but the derivative of the secant is secant tangent. So what do you need to do? Well, instead of just having a secant at the end, you actually need secant tangent at the end, and whatever in front, change to what? Well, look at the tail. The tail is secant tangent. Secant tangent is the derivative of what? Secant. Okay, that is when the power of tangent is odd. Okay, so we do u substitution, let the u be secant, and secant tangent is going to be du. Second case, if the power of secant is even. Oh, this is different than the previous method. Previous method, we look at whether the powers of sine or cosine is odd. Here, for tangent, we look at when it's odd. For secant, we look at when it's even. So when it's even, we're gonna split secant square at the end, and then whatever in front change in terms of tangent. Because the secant is even power, after you split secant square, the remaining is still an even power. So when it's even power, then you can change it in terms of tangent using the trig identities. After you're done, let u be tangent, and then du is gonna be secant square. So far, so good. And the third case means when the power of tangent is even and the power of secant is odd. in this case, it really depends on the problem. And today we will do some example and I can teach you some tricks. Okay? But if the guideline is not as clear as the previous case, you know, for the products of powers of sine and cosine, we have the double angle formula here. We can use that. All right. Okay, let's see. So, example 2. All right, let's see. Here, part A. You see the power of tangent is odd, right? So if the power of tangent is odd, what do we need? Well, we want to have secant tangent at the end. Well, but you say, there's no secant here. What do? It's okay. We can borrow it from the bank. So, what do I mean? You can divide by secant and multiply by secant, so too you can create this factor. So we borrow it from the bank. Okay? So now what happened? Okay, remember this is the tail of secant. This is the derivative of secant. So we're ready. We can let u be secant x, then du is secant x tangent x. So that's why we have integral 1 over u du. Oh, that is ln of absolute value of u. Okay, slowly. And our u is secant. Okay, so we can do it like this. So remember, if you don't have a secant and you want to match a secant tangent at the end, borrow it from the bank. Okay, next. Okay, so actually there is another method. Okay, some students say, I'm really not familiar with the products of tangent and secant. It's okay. Then you can change them in terms of sine and cosine. So tangent is sine x over cosine x. Well, then you can work with sine and cosine because now you see, we can let u be cosine x, then du is minus sine x dx. Well, this is the same as minus du over u. Well, it's negative ln of absolute value of u, and the u is cosine x. Okay? Oh, some of you might ask. Okay. Some of you might ask, oops. All right. Okay, some of you might ask, are they the same? Let's see. Okay. Some of you might ask, are they the same? Yes, actually they are the same. Because you can secant is 1 over cosine, right? So this is like cosine to the minus 1 and you pull out the minus 1 in front. Don't do that because this notation means inverse functions. Okay, so you know that the exponent is minus 1, you put it in front, then you get this. So they're actually the same. See? Now we can use both methods to solve. Alright, continue. Okay, so here we have integral of secant. So what is the integral of secant? So, integral of secant, you can see this guy, the power of tangent, there's no tangent, so power is 0. 0 is even. And the power of secant is 1, which is odd. So we are in the third case. So, we don't have a strict guideline. So for this particular example, the trick is we multiply by secant x plus tangent x, and we divide it by secant x tangent x. Well, you may ask, why? Actually, People just try it and it works. And it only works in this example. Okay? Because after you multiply it, wow, do you see something interesting happen? The derivative of secant is secant tangent. The derivative of tangent is secant square. So the derivative of the denominator is actually becomes our numerator. So we can let u be our denominator. Then the numerator is just gonna be our du. So that's why we have integral of du over u, which is ln of absolute value of u. Okay, so that's why here we have ln of absolute value of secant square. Oh, sorry, u is secant x plus tangent x plus c. So far, so good, everybody. See, we have learned the integral of tangent and integral of secant. So do you remember at the beginning of this semester, when we talk about the antiderivative formulas, we said, okay, we know how to integrate, so let me review of you. We know how to integrate cosine, right? We know how to integrate sine, and we know how to integrate secant square. We know how to integrate secant tangent. And now we learn how to integrate tangent, and we learn how to integrate secant. And furthermore, same idea, we can integrate the cotangent and cosecant. Oops, I realized I have a typo here. So far, so good, everybody. All right, let's continue. Okay. Okay, so let's continue. We want to find evaluate this integral. So now you can see what is the power of tangent. O is not an integer, so we cannot talk about even or odd. But the power of secant is even, right? When it's even, what do? We split a secant square at the end. What's left? Secant square, right? We still have secant square left. And now what happened? Look at the tail. Secant square is the secant square is the derivative of tangent. So change this in terms of tangent. Alright, so that is integral of tangents a over 3x. Secant square is 1 plus tangent square. And we have secant square dx. Yeah, sometimes students get confused. Oh, shall I change tangent in terms of secant, or shall I change secant in terms of tangent? Look at your tail. Okay? Secant square. What is the secant square is the derivative of what? Okay, so look at the tail, then you can find the animal, right? So that's why we know we must change them in terms of tangent. Okay. So now we're ready. Let u be tangent x. Du is secant squared dx. And then we have integral of u to the 8 over 3. And then 1 plus u squared on du. Remember, no product rule, so let's distribute it. So u to the 8 over 3. And then plus, well, we 2 is like 6 over 3, so 14 over 3 u. So far, so good, everybody. So when we integrate, add 1 to the exponent, so 11 over 3 over 11 to 3, we can flip it on top. And then u to the add 1 to it, so 17 over 3 over 17 times 3 plus c. So far, so good, everybody. Okay, finally, what is our u? Tangent. So 3 over 11 tangent to the 11 over 3. And then 3 over 17 tangent to the 17/3 plus c. So far, so good, everybody? All right, let's continue. Okay. All right. Okay, so tangent x cubed. So what do we do? Well, here, the power of tangent is odd. Then what shall we do? Well, we're gonna split one of the tangent, but what we want to see is secant tangent at the end. So what do we do? Well, if you split a tangent at the end, what's left? Tangent square. And you borrow a secant from the bank, so you also need to return it. So you multiply by secant, then you also need to divide by secant. So they are still equal. Right, everybody? Okay, so now remember, this is the tail of secant. So change the tangent in terms of secant. So tangent squared is secant squared minus 1. And then we have secant tangent dx. We're ready. Let u be secant x. du is secant tangent dx. Alright, so this is u squared minus 1. This is 1 over u du. Well, let's distribute it. U squared over u, that's u, and minus 1 over u du. Integrates, integral of u is u squared over 2. Integral of 1 over u is our absolute value of u. And what is our u? U is secant, so secant squared over 2 minus ln of secant x plus c. So far, so good, everybody? Alright, so let's continue. Oh, so the next problem is actually very similar, right? We also split the tangent, okay? But you need secant tangent at the end. So let's see. Let's copy this down. What do? We want to divide it by secant as well. So now change this in terms of secant. So this is secant squared minus 1. Don't forget the parentheses. Well, then combine this together. What is this guy? Well, you own the bank $4. Now you own $1 more, right? So negative 45 minus 1 is negative 9 over 5. And then secant tangent. We're ready to let u be secant. du is secant tangent. So u squared minus 1, u to the minus 9 over 5. Okay, du. So distribute it. U squared. Square is 10 over 5. So this is u to the 1 over 5 minus u to the negative 9 over 5. Right? du at 1. So 6 over 5 over 6 times 5. At 1. U to the minus 4 over 5. Oh, minus 4. 5 fell on top. Plus c. So finally, what do? We change the u to secant. So 5 over 6 secant 6 over 5x plus 5 over 4 secant to the negative 4/5. And this is our answer. So far, so good, everybody? All right. Let's see. Okay, so let's continue. All right. So next, we have this reduction formula. So the idea is we use integration by parts, and so here is integration by parts. Okay, so by the integration by parts, we can get all of this reduction formula. Okay, just a proper choice of u and dv. Okay, for example, here you're gonna split one of the factors, so sine n minus 1 x and sine of x dx. So you let this be u and you let this be dv. Okay, and then integral of the dv, so v is gonna be negative cosine. Okay, so by the integration by parts formula, then you can get this. All right. Okay, so next